In this video, we will see about the topic fuzzy logic. So these are the agendas of what we are going to see in this topic. What is fuzzy logic? Why do we use fuzzy logic? Architecture of fuzzy logic, membership function in fuzzy logic, difference between fuzzy logic and probability, applications of fuzzy logic, advantages and disadvantages of fuzzy logics. After seeing all the topics, we will be seeing the example of fuzzy logic. So this is the formal definition of fuzzy logic. Fuzzy logic is a method of reasoning that resembles human reasoning. So it is a method in which it the agents what we are designing will be trying to provide a solution, provide a reasoning pattern similar to that of human reasoning. So this is the earlier we studied about the logics like propositional logic and predicate logic. So apart from that, either in propositional logic or predicate logic, we will be going with only two conditions, either true or false, or we can say it as 0 or 1, or yes or no. This kind of a scenario only happen for any kind of given facts. But there are so many intermediate values between that lies between 0 and 1, as like 0.24, 0.4, 0.8, 0.9, 0.95. So many values or so many possibilities of values are lying between 0 and 1. In order to address those values and also to find the truthness and exactness of that, and also to avoid the vagueness of those particular values, then we are going for that only we are going for this fuzzy logic. So in next point they have given this approach is similar to how human performs decision making. This fuzzy logic also helps we are using to support humans on performing decision making, on performing better decision making. For that only we are going for this fuzzy logic. So it will be better if you have something about that particular concept or something, and yeah, always there will be saying like it is something is better than nothing. So as of that one, some information related to that particular problem and addressing those problems will definitely take us to the better solution. So that is what this fuzzy logic involves. And as I to state earlier, it involves all intermediate possibilities between yes and no. So this is a formal definition of fuzzy logic. So here they have in this slide they have given the um, difference between the major difference between the fuzzy logic and the Boolean logic, which is classical logic. So if the question is it cold, then you can say with the help of Boolean logic, we can tell either it is cold means, if it is cold means yes, we can tell, or if it is not cold means, then we can go for no. Then what about the remaining? If it is a little cold, then if it is very chill, then what kind of what these kind of values should also have an impact on the results. For that only, so we are going for, if in fuzzy logic, if the question raises is it cold, then we have here we have given three possible values, which is very much cold, a little cold, and simply cold. Okay, normally cold. So that is what is given as 0.9%, 0.25%, and 0.10%, that way. So this is what it is how the information will be represented in fuzzy logic. So next things, what is generally a fuzzy logic? So as I told earlier, the conventional logics, it contains only either true or false, or yes or no, or 1 or 0. But the fuzzy logic, which is invented by Lotfi Zadek, observed that he included all the ranges between uh, 0 and 1, which is yes or no. So he classified the possibilities as five categories. They are certainly yes, possibly yes, cannot say, and possibly no, and certainly no. So these are the values he considered for representing the fuzzy logic. Next comes the the implementation. So where this fuzzy logic can be implemented means it can be implemented in different kinds of systems like microcontrollers, large networks, workstation based computers, hardwares, softwares, and in combination of both. Uh, all of this involves the implementation of fuzzy logic. Everywhere it can be implemented, either it may be hardware or software. So why do we use fuzzy logic? So next slide comes, why do we need fuzzy logic? So it there are different practical and commercial purposes are there for using the fuzzy logic. So some of them are listed here, which is it controls machines and consumer products, which means it will control the machines, and it makes us to it makes the machine to take a better decision. So that is what it is given us. It controls machines, and if not accurate reasoning, it is at least provides acceptable reasoning. So even though it is not, when we go for fuzzy logic, when the information is either partially available or little information is available, so then we go for that fuzzy logic. So even though if there is a not accurate reasoning, it at least provides acceptable reasoning. So that is what it is, the fuzzy logic is, and it helps in dealing with uncertainty in engineering. So this is the major application of this fuzzy logic. Because most of the engineering concepts, it deals with it has to be dealt with uncertainty, which means unclear data or partial data. So here fuzzy logic majorly deals with the uncertainty in engineering. So these are for these purposes we can go for the usage of fuzzy logic. So here is the architecture of fuzzy logic. Here you can see the four components. They are rules, fuzzifier, defuzzifier, and intelligence. So before seeing what is fuzzifier and defuzzifier, let me tell what is rules and intelligence. Rules is nothing but set of rules or set of conditions that to be followed when applying on the particular inputs. So with the available rules only, we can say in uh, in in this architecture it is called as rules. But the earlier architecture, earlier things which we want to compare means rules is similar to knowledge base. So that is the one thing which is rules. And next component is intelligence. So intelligence here also represents a inference engine. So applying the rules with the given informations, it will infer new informations, or with the available facts it will try to prove applying new rules, and it will try to infer the new things or already given facts. It will try to prove the given facts. So next comes the fuzzifier. So fuzzifier is a component that takes the input as crisp input, that takes crisp input, and it will it will take the crisp input, and it will classify the it has five classifications as I stated in the previous slides. Possibly yes, possible mostly yes, mostly yes, possibly yes, so some cannot say, and mostly no, possibly no, and mostly no. So in these five categories it will categorize the inputs which it got. So and based on the classification it will categorize the input, and it will produce the fuzzy input set. So that fuzzy input set will be fed into the intelligence, and the concerned rules will be applied in order to infer the particular under which classes or which classification that particular input set falls. That will be identified, and based on that, similar to fuzzifier, defuzzifier also has five inputs. So five classifications, five, which means here we can say precisely as member functions. So as of fuzzifier, defuzzifier will also have four to five classes. So upon based on the corresponding output which is given by the intelligence, it will be categorized, and it will be produced as the crisp output to the to the environment or to the agent what it is, where it is acting, it is being acted. So these are the four components of fuzzy logic architecture. They are rules, intelligence, fuzzifier and defuzzifier. It will take the crisp input and it will produce the crisp output. So these are the components that are detailedly explained. Rules, it consists of all rules and if then conditions that are being defined by the experts in order to make a better decision making systems. So it provides effective methods for design and tuning of fuzzy controllers. So these are the rules. It consists, in simple words, we can say it consists of all the rules and conditions to be followed. Next comes the fuzzification. As I explained in the architecture, fuzzification consists of different sets in which the input will be fed on the corresponding class fuzzy set and the corresponding actions will be produced as a fuzzy input. So this step converts input or crisp numbers into fuzzy set and by sensors and pass them to the control systems for further processing. Here they will be, it has five classes, what is, which are large positive, medium positive, small, medium negative and large negative. So among this one classification, the input will fall, definitely falls, and its corresponding process will be happening. Next comes the inference engine. In architecture it is given as intelligence. There itself I explained inference means intelligence means inference engine. It determines the degree of match between fuzzy input and the rules. It will apply given rules will be applied and it will be performed, it will be performing inference, the rules will be applied and the inference engine will be inferring the information and it will be taken given output, it will be firing the output as the fuzzy data output. Then comes the defuzzification. Defuzzification process converts fuzzy set into the crisp value and it will be, best suited one will be given as the output. So this is defuzzification. So how many functions are there in fuzzification? Similar functions will be there in defuzzification also. For example, if you take a speed of temperature of a room and the speed of temperature of the room as the input and speed of the room fan as the output, means if the temperature is classified as cold, warm and hot, cold, warm and hot, then the output defuzzification sets will contains fan speed. As I told, it consists of fan speed. Then it may be classified as slow, medium and fast. So if the room temperature is cold, then the fan will be setting to slow. If the room temperature is warm, then the fan temperature will be set to medium. If the room temperature is hot, then the fan speed will be set to fast. So this way the in processing will be happening with the help of fuzzy logic. Next comes the member function. So member function is a graph that defines, with the help of member function only, we will be trying to plot the we will be trying to plot the inputs what we are having in the range between 0 and 1. So member function is a graph that defines how each point in the input space is mapped to a membership value between 0 and 1. It allows you to quantify linguistic terms, which means, as I told earlier, very hot, very cold, little cold. These kind of linguistics, which means local language or local language representation, can be represented in a graphical form. So any quantifiable formats can be used to it can be represented in the fuzzy logic kind of categories with the help of member function. So the member function for a fuzzy set A on the universe of discourse X is defined as mu A colon X, where X represents the value between 0 and 1. So here it quantifies the degree of membership of the element in X into the fuzzy set A, where X-axis represents the universe of disclosure and Y-axis represents the degree of membership. In the next slide, I will show the application membership functions sample graph. So here you can see it is being, I will zoom little. So here you can see that it consists of the x-axis and y-axis. Here we are representing x-axis and y-axis. In x-axis we are representing the input voltage, and in y-axis we are representing the membership functions. So in x-axis we can see that the value ranges from -10, -5, 0, and 5, and +10. So plus 5 and +10. So -10 we can represent it as large negative, and -5 we can represent it as medium negative, and 0 we represent it as small, and +5 we represent it as medium positive, and +10 we represent it as a large positive. So and the membership function, as I told, it ranges from 0 to 1. So it has given us 0, 0.5, and 1. 1. If any, this is the sample membership functions. So this kind of membership function will be represented for both input data and the output data. So input data it will be different, and output data it will be different. So it will have it will not have common member function for any particular process. Input data will have different membership function, and output data will have different membership functions. So that is being here I have simply represented a simple membership function, and mostly all the membership functions, not all, mostly the membership function makes use of this triangular membership function shapes, because um, most of the values fit into this particular triangular shape. So that's why we are, most of them they are using triangular membership function for any kind of data representation. But other than that, other membership functions also is available, like sigmoid membership function, and so many others are also available. Most commonly used is one, triangular membership functions. So it here for this particular in example, which is I have given in the previous slide, it consists of 5 level falsifier. It ranges from -10 volts to +10 volts.